All right, so I think we'll get started here. Welcome, everybody. This is our Enlightened Soil Corp webinar with Herb Young. My name is Camille Newsom. I am the Director of Grower Support here. Yazzie, who is not here with us tonight, is here in spirit. She is down under in Australia. And we have a special guest tonight, Herb Young, who is a BeCrop Advisor and works at has his own citrus farm of Squeeze Citrus LLC. And he has been working with us with EnSoil Algae, both with citrus and with peppers in Georgia. And he's going to be able to tell you a lot more about that tonight. So we're super excited to have him. We are going to be having him present for about the first 30 minutes. And then after that, we're going to open it up for questions and discussion as we typically do. It's really exciting to see a lot of new names and faces here tonight. We appreciate you being here. So typically, if you have questions during the presentation, feel free to type them in the chat, write them down. And then after the presentation is over, we will open it up for discussions. You can unmute yourselves. We'll stop the presentation and have a conversation. So we hope that you enjoy the webinar. And with that, I will introduce Herb. Thanks for being here, Herb.
Yeah, thank you so much. I appreciate this chance to do this. I want to give a little bit of background about where I am right now. I spent 38 years in the ag chem industry, decided to retire and grow citrus. And in doing so, I discovered regenerative and organic, and what a exciting way to grow and to work on the soil particularly. So I planted a grove. I've got, it's small citrus wise, it's 1,300 trees. I'm packed onto 5 acres. And these are some of the goals that I have growing regeneratively. Ultimately, it's to have a more healthy tree based on the health of the soil, high bricks in the tree and also in the fruit, tight internodes, which you kind of see on some of these pictures, a dense tree. Ultimately, that could lead, hopefully, to low insect pressure. Something that's important for citrus growers, we strive for as many flushes of leaves as we can. We get an entire new flush of leaf on the tree. We can get up to 5 flushes a year. So that's my goal. If the trees are ultimately healthy, I'd have that higher level of growth. So to grow regeneratively, I feed the microbes constantly, either with root exudates from these cover crops or just literally through the irrigation. I send a lot of food to the microbes. And the ultimate desire commercially is to end up with nutrient-dense fruit. So one of the things that I do is grow cover crops. And this is how nice and lush they end up getting in the wintertime. And it's clovers, hairy vetch, Austrian winter pea, ryegrass, black oats, daikon radish, kale, turnips, and then I mow it to the row always. So I'm trying to provide nutrients back to the tree, let my cover crops provide nutrients, and then really provide habitat for microbes and keep the temperature down, help hold in moisture. So I plant 10 different species of cover crops in the fall, and then a different 10 in the spring. So one of the satisfactions that I've gotten, or proof that things are working, is with a penetrometer. You just put 200 pounds of pressure on it, and in the middle, it penetrates about 3 inches. So that's the natural compaction of the soil that we have. And when I go between the trees in the row, the penetrometer, it goes at least 2 feet in. A lot of times it just sinks easily all the way to the handles. It's pretty amazing. So it's a combination. This is roots from the cover crops, roots from the trees, but really it's the microbes are adding a lot porosity in the soil. So hopefully that's going to really help trees as they grow. This picture was taken just after the terrible freeze that we experienced a little over a year ago. So everything is in tough shape. This is one of the results that I've started to see. My trees are just 3 years old. One of the first fruits that I got were page mandarins. And on the right are the page mandarins out of my grove. And then I went to a commercial grove about 15 miles away that had page mandarins and picked them. And there's this dramatic difference in color, flavor, aroma, and everything. So my hope is I've juiced both mandarins and a grapefruit variety from a different conventional farm and hope to send them to a lab for nutrient analysis so that we can actually have some documentation of what regenerative organic practices are doing. So I want to shift, and that's enough about me. We're going to look at EnSoil Algae. I've done two sets of trials. One was on my own grove on citrus, some real interesting results. And then another was on a large commercial vegetable farm, a trial on peppers. But this is a discovery of Dr. James White at Rutgers. And this is just quite incredible. And it revealed a lot about EnSoil. EnSoil is Chlorella vulgaris, which is an algae species. What Dr. White found out is that not only does the EnSoil, the chlorella, go into the root as an endophyte, but it is full of bacteria, so it carries them into the root. So it's a carrier, and then it also has its own endophytes, which it releases into the root. So this is an exciting discovery, and if you've ever watched Dr. White's work, it's incredible, this definition of the rhizophagy cycle, which is purely the interaction of endophytic bacteria, which are living in all of our plant roots, and they actually stimulate root hair development. So the trials that I've done have just been a small step to try to elucidate a little bit what the effect of EnSoil and its bacteria that it carries on the microbiome, and then ultimately on the plant, the crop plant. So this is the trial that I did on my own farm. I put everything I do is, because I came from research. I did 25 years of field testing with a couple of different chemical companies. And so obviously everything we did was replicated, and that added validity, we felt like, to everything we did. So on my own farm, it's really turned into a research farm. I have about 10 different varieties, but most of the blocks I've got them flagged off into replicated trials. So I put out this trial with EnSoil Algae, and I put it on 2 different varieties, which was very interesting. I used page mandarins and honeybells. And I got different responses with the 2 varieties. So they were at probably different physiological stages. So when there was a soil impact, they responded differently. But this was the effect of EnSoil. The one on the left is a soil treatment. And so what we were actually testing was a soil treatment or a foliar treatment going to be better with EnSoil. And the foliar treatment, although there was some soil responses, there wasn't a visual response above ground in the tree. So this is what I saw. So it took the most important thing, like I mentioned, to me was leaf flush. And so I, from the timing of application I measured leaf flush at 2.5 weeks after application, 5 weeks, and 8 weeks. And this is what happened. These are the results on the page Mandarin. So the 3 graphs on the left are the 3 timings, and those are the soil applications. So I was at over 50% leaf flush at 2.5 weeks. And then obviously the flush happens and then it declines. So the foliar spray was, just barely visible, 20%, just the same as the untreated. So the foliar spray, and so their initiation of leaf flush was really after 8 weeks. So essentially what happened with EnSoil is we moved leaf flush 5 weeks earlier than it would have been, which is quite dramatic and something that's real significant in what I'm trying to do to pack in those 5 leaf flush during the year. So the question is, why did it do that? So in addition to the above ground evaluations, the numbers that I took, we did quite a few tests below ground. We did a Haney soil health test on each of the 3 treatments, untreated, foliar, and soil. And then we did a Biomakers BeCrop. And if you're not familiar, I think I'll take a minute and just and jump over to the BeCrop. And I'm actually going to show you results of my own farm. Let me know, Camille, if this went over.
You're good. We
so
got it.
This is what a BeCrop test looks like. So it's basically it's a window into the soil. Every circle in this diagram is a separate species. And so it says up at the top, this is my regenerative treatment after, this is on my trees in a different trial. I'm just using this to explain and to visualize what BeCrop does. I have a large replicated trial, 135 trees, that's conventional, regenerative, and then a third treatment that's indigenous. So it's not adding any foreign microbes, just waiting on indigenous. So the indigenous and the regenerative are both completely organic. And then the conventional is Roundup, bare soil, granular fertilizer, synthetic pesticides, just what a traditional grower would do. So this is what I love in the regenerative. What you see here is diversity. Their results are really interesting. You can click on any of these groups at the right, and it pulls up just those species. Archaea, these are the extremophiles bacteria. Every one of them are nitrogen fixers. So that's neat. The bacteria, there's a lot of diversity. So total, there's 1,064 species were detected in my regenerative sample. That's the different bacteria. The nice thing is there's a lot of diversity, and they're in relatively small quantities. There's just a few ectomycorrhizal fungi, no endos, or just one, and a few yeast, and the fungi. So this is great. And obviously, anybody with trees, the goal is to get a high fungal to bacterial ratio. Ultimately, we'd like it to be 5 to 1 or better. But you can see from the total, I think I've reached 1 to 1, and maybe it's a little bit better. In total quantity, the size, each circle is a different species. Here's the largest fungi is Curvularia. It can be a leaf spot pathogen, especially to corn, but mostly it's a decay fungicide. I generally look at this, and then I go through and find there's penicillium, which is great. Pyrrhinocatopsis, 2 of those species, and an aspergillus, which can be a can be a pathogen, but the diversity is great. And I'm going to switch over and show you the conventional. This is the conventional treatment. Roundup, bare ground, completely different situation. One fungal species, Lycoperdon, has dominated and taken over. It's 89% of all the fungal species that are detected. Lycoperdon is the dwarf puffball, absolutely worthless. I assume that it's driven out most of the other fungal species. If you look, there's not much of them left, and they're in extremely small quantities. So basically, with the bare ground and synthetic treatments, which there have been a couple of fungicide treatments applied to the tree and another one to the soil, but the bare ground basically has caused this conversion. The field started more like what the regenerative looked like, a decent amount of diversity. Up at the top, it says there's 836 species there. So 200 less species than in my regenerative, but incredible visual of what's going on in soil when it's farmed conventionally. And then the other thing that's so evident here is the bacterial to fungal ratio. So totally dominated by bacteria. The archaea, about the same amount. So they are holding fast, but a lot of bacteria species. So it looks to me like we've doubled or more the bacterial species. So that's there's a lot of ways to look at. This is a dashboard of a BeCrop sample sent to biomakers. So I've been able to follow this test of mine for 3 years. So it's fascinating to look at it and visually almost have a window into the soil and see what's going on. So I'm showing this to show that we have taken those same BeCrop samples in this trial and in the pepper trial that I'm gonna show also. So what was going on in the soil? This shows that there was a little bit of an increase in the number of species, probably not significant, but one of the things that biomakers does is they categorize all of those species that they find, and they know the effectiveness of each one, what it does, if it's a nitrogen fixer or if it opens up phosphorus pathways or potassium. There's actually 40 different categories that they place all of the microbes into, and then they give kind of a summary of what that community of microbes would do for each of those hormonal and growth responses and anti-biological effects, bactericidal, fungicidal. So both of the treatments, foliar and soil, had an impact on nitrogen pathway, phosphorus and potassium pathway. The soil one increased biodiversity, which there's a fascinating component to it. So the Haney soil health test actually proved that biodiversity. There's a measure of how much microbial activity is going on. But the most fascinating thing I found from that, the soil out of the treated that had the EnSoil on it, they measure, the Haney measures both nitrate nitrogen and ammoniacal or ammonia nitrogen, form of nitrogen. And there was really not much change in the untreated and the foliar treatment. But in the foliar, the soil applied EnSoil, the nitrate completely disappeared. So to me, I mean, we know the cycle that the microbes go through. They convert nitrate to ammonia, ammonia to peptides, peptides to amino acids, and then finally to proteins. So the nitrate disappeared. So the microbial activity was consuming nitrate almost all of the ammonia disappeared. So it showed when the EnSoil was treated, that test showed basically no nitrogen left in the soil. It had all been converted to amino acids and proteins. That was an exciting validation. Both of these things validated what I saw above ground, which was that leaf flush response. This is another one of the way that EnSoil, the BeCrop test, shows visually what's going on. Carbon and then NPK. The blue is a higher value than the yellows, and the dark yellow is the least amount. So both the EnSoil treatments showed a numerical response there. And then I looked at the literally, this is called Explorer in BeCrop, and saw these. So here's some of the results that have indicators of what's going on. So you see, I picked the largest fungi or the largest bacteria was Sphingomonas, which is basically a decay bacteria, and it declined. It was 12% in the untreated, and it had dropped down to 5% when EnSoil was applied to the soil. And then you see the fungal presence. Some of the fungal species increased when the EnSoil was used. So probably a lot of things going on in that soil that it'll take time to discern all those things. So in Biomakers, you can actually use a different format and compare 3 treatments at a time. So I picked out species that had high levels and put them into this format. And the untreated is the one on top. And then the foliar is the purple, and the reddish is the irrigated. So it was the soil applied. So looking at different species, Alternaria with the soil applied was greatly reduced. Interesting. Streptomyces, which we all know is a beneficial, really dramatic increase, tripling of in the soil applied EnSoil. Mycobacterium, which is a nitrogen fixer, and it does decomposition. And this one jumped up 3-4x with the soil application. All of these are indicators that there's a lot going on. And then this one is the real mystery. We always think of Fusarium as a pathogen, but there has been tremendous new work showing that several of these pathogens, and Fusarium is the one that's been used as a test case over and over, until it detects a weak plant, it's a beneficial in the soil. So my first glance, I thought, oh my goodness, we've doubled, quadrupled the amount of Fusarium. But if the trees are healthy, then the Fusarium is actually acting as a beneficial. So that's the results of the trial that I did. The exciting thing was to see that EnSoil, when it was applied to the soil, caused some real significant activity and the tree responded by a real change in growth pattern. Now, as I mentioned before, the change was really in the page mandarins, and I didn't see a visual change in the Honeybell variety, although those samples were pulled from both varieties mixed. So the same activity was going on in the soil, but in that case, the Honeybell didn't respond to that in the same way that the other variety did. So let me shift gears a little bit, and we're going to have plenty of times for questions. But now I want to go to this commercial pepper trial that I did with with Enlightened Soil. It was in Cool Springs, Georgia. Southern Valley is a large commercial vegetable farm. To set it up a little bit, we actually did this time. The blocks are so large, the field was 10-acre blocks. So we did replicates, 3 replicates within each of the 10-acre blocks. And we tried to match as close as possible 2 blocks that were adjacent to each other. They actually almost wrapped around each other. And this was the timing of the applications. So we did the injection with the grower's help into their irrigation system. So we picked one of the 10-acre blocks and injected EnSoil Algae. And the grower was applying a significant amount of biology himself. So he did quite a variety of different things. There were some commercial inoculants and several that he fermented himself. And he had 7 times during the growing season, he actually added biology to the field. So there was a lot of activity already there. And we chose to do our applications 2 at the front stage. So this is the first application timing. Probably it's just a little more than 2 weeks after the transplants went in the ground. And then we did a second one, second application 14 days later. So the thought was get the transplants a really good start with the help of EnSoil. And then we waited until harvest began to do the final and third application, hoping to give the plant a boost late in the season. So it was actually 7 weeks between the first 2 applications and the final application. But the final application, there were 7 harvests, and there were actually 9 harvests, and the last application was synchronized with the second or third harvest timing, depending on the field. So here's a diagram of the field. Block A, 9.5 acres, was the treated. And then block B, which is adjacent to on one side, and then it's on the other side of a pond. That dark area in between A and B is the irrigation pond, which is going to end up turning out to be very significant in this. So all the irrigation water comes from that pond, and anything that's injected for fertility or biology or the EnSoil comes from water in the pond. So this time BeCrop, because it was a replicated sampling, they did an incredible analysis of those 40 categories that they group everything into. And these were the categories that came out with statistically significant differences. And it's pretty exciting. There's 12 real changes that we saw out of those different categories. If you just kind of look down that list, nitrogen release, phosphorus assimilation, iron assimilation, 7%, sulfur, gibberellic acid production, 40% increase. This is just the EnSoil compared to the untreated. 40%. Heavy metal resistance, 70% increase in that activity, highly significant. Abscisic acid, which has a whole list of hormonal effects, and siderophores, which I actually had to look up and remind myself that they do iron chelation, they do some biocontrol, and then they have quite a list of PGR, plant growth regulator activity. So a 38% in siderophores. And then, as you can imagine, because this population changes with the EnSoil, which It's bringing in bacteria inside the algae. So we've got this absolute explosion in the bactericidal agents that are detected. 21,000%. And fungicidal agents went up 280%, so tripling. Nematicidal agents doubled. And then gray mold was reduced 74%. But let's kind of glance through some of the specifics, pull out some of these specific microbes. Globosporangium is actually what we used to call pythium. And so on the top are the pre-treatments, which 3 reps out of each side. So six pulls, a lot of variability in this pythium pathogen, which is a real, it's so similar to Phytophthora, and this farm has a battle continually, especially in several of these crops with Phytophthora capsicii. Pythium is more of a seedling disease, and we put them in as transplants. So you can see between the pre-sample and then just 7 days later, big drops. And the drops occurred both in the EnSoil and the untreated, but interesting to see the dynamics of what's going on in the field. Didymiella is actually a pepper disease. It's a stem rot. Same thing, very interesting between the pre-sample and then the 2 sets of samples later on. A big drop in Didymiella, but you can see there is one sample, there was a hot spot in the field detected way out on the right. 54% of all the fungi were Didymiella in just that one sample. So you also see the variability within the field. On this one, you can see the light blue circles are actually the pythium. So several different pythium species that are there in this field. High levels in all the samples. This Phingomonas, which is beneficial, it has some phytohormonal effects, and it remediates environmental contaminants. Really interesting. Hadn't heard of it before until I started pulling these BeCrop samples. So really nice increase as the season goes on. You see these big jumps. And then this one absolutely threw me for a loop, Alternaria ecornii. And this really concerned me when I got the samples back and could not figure why we had this incredible jump. And I'm going to show you what it looked like in the samples. I pulled out 2 of the untreated and then 2 of the EnSoil. This is an Alternaria species. But finally, I looked it up. It's actually a pathogen of water hyacinth. And we are irrigating out of a pond which had water hyacinths around the edge. So what a story to realize that pond water is bringing its own pathogen. Now, it probably doesn't carry over into any above ground plant that we know of, but how dominant it became just by irrigation out of this pond water and the amount of inoculum load that it's bringing in and probably altering a lot of the species, the balances that are there going on in the soil. But what's the ultimate good effect? Before we go into questions, I'll just say that the EnSoil treatment, that 10-acre block, had a 13% yield increase. Doesn't sound huge, but so yield was taken. This grower's meticulous, counts every box of fruit that comes out. 45,000 pounds in the untreated and 51,000 pounds of peppers. These are bell peppers. In the EnSoil treated block, it's a 6,000 pound increase in the EnSoil. Now, I checked on the price. The average price of pepper during that season was 68 cents a pound. So a 6,000 pound increase translates to a big financial effect. The goal when we do it in the future, there were other blocks of peppers nearby, and there is some variability when doing trials, yield variability just from these great big blocks. But our goal is to try to do the trial again, either in this crop or a different crop on their farm, to find an area where there's more blocks and actually use the blocks as replication. And that would add a lot more validity to the yield response. So I'd like to turn it over now. And Camille, any way you want to manage this?
Thank you so much, Herb. It's so exciting to hear this projected. I've been looking at this data and putting it in our field report and everything, but hearing you talk about it is definitely even better. So you can, if you want to stop sharing, Herb, we can see everybody or anybody who wants to be seen. And feel free to unmute yourselves, throw questions in the chat. I'll read them out and we're going to have a little conversation. Mary, you want to start us off with one? You're on mute.
Thank you, Brad. I see your comment.
Hi, everyone.
Hey, Meredith.
How are you?
Great.
Yeah, I agree with Camille. I've read and poured through all of these reports and we've gone over them so many times that it's a proud moment to hear them projected and reviewed here and shared. Yeah, I would love, I don't know what everyone's experience here is on the call, but I loved that when we learned that about fusarium, and if there's anything that you can, elaborate on, overabundance of some species and how they affect plants. And I know one thing we've seen with the bee crops in the past is this balancing of fungal to bacterial ratios, per crop. I've kind of been explaining that as crop needs based on crop needs. So could you talk about that where you've seen that elsewhere?
Was that to me or to anybody?
That's to you, Herb. Or that's to you, Herb. Or if anybody else has anything to add to that conversation.
It's almost like it's new science. The things that we're learning about how a pathogen is not. It's not that simple. It's not just a pathogen. But in hearing you say that, it actually makes me think. Those slides I showed of my own field, regenerative versus conventional, that regenerative has gotten EnSoil in the last 2 years over and over again. So I've used it probably 3 or 4 times a year. And then we saw that beautiful increase in fungal population. And so it's now, I think, outpacing bacterial, which is the direction I want to go. So yeah, EnSoil could certainly be playing a big part in that. That's an interesting idea. I hadn't thought about it exactly that way. Be interested in anybody else's experience or things they've heard about this new way of looking at pathogens.
This Jack, I have a question on your comment you just had. You said you've been using EnSoil the algae for 2 or 3 years. Have you seen an increase in your fungal bacterial ratio as you progress through the years?
It's been dramatic.
Herb, you're having some connection issues.
In my group, 45 trees that are just conventional, and so they've never gotten EnSoil. Are we locked? Is it?
Yeah, we can hear you now. Would you mind repeating what you just said? I think a lot of us missed it.
Yeah. So because I do have an untreated that's never, it's never gotten any biology, it's just been treated completely conventionally, and it's 3 reps, 15 trees in a row. So it's 45 trees. And although, I mean, it's frustrating, the trees are growing well, but they're in that almost sterile environment that's being dominated by that single fungal species that's a puffball. Just completely of no use. I've lost all the diversity of fungal species. So now it's gotten other inoculants, mycorrhizae, which I don't think took a lot of bacterial inoculants, and it's just gotten, the microbes have been fed. So, but EnSoil was one of the big contributors, something that I used regularly in that block. And I think it was a big transformation.
But I guess I missed it maybe while you were locked up. Over the years, did you see a linear increase, or how did it change over the time period?
Yes, it changed dramatically. So the fungal ratio went down significantly, especially in this last year, which was the third production year. The fungal ratio dropped way off, and it's increasing steadily in the regenerative treatments, which include EnSoil as one of the major inoculants that I use.
Thanks.
Hey, Herb,
Yes.
this Thor Hatton down in South Florida, we spoke on a couple other biomakers webinars, and
Sure. Yes.
I think you shared with me that you're not affected with HLB yet, are you?
We are not, fortunately. Yeah. It's not made its way here. I'm afraid it will.
Well, probably unfortunately, but I wanted to ask you a question. Do you see a marriage between what we want to call regenerative or using biology in unison with our conventional means of, cultural practices on citrus?
I think definitely. So there's some things obviously which can hurt. I think that probably Roundup strips for bare ground is a detriment. Some of I mean, every step in organic or regenerative is probably helping the microbial community, the population down there. But I think cover crops are a real significant one. Even if they're out in the row, we know the citrus roots are going all the way out there. So that's a contribution to the soil health and the citrus health. My hope is if I can see some differences, I mean, since I am HLB free, I'm sort of almost like a test tube environment, that if I can find and show some things that maybe it'll have some pertinence just to general tree health, that it would be harder to test in your HLB environment down there. So maybe we can determine some things. My goal is that I see a significant difference in fruit. Next year, when I get fruit off of that conventional versus regenerative trial, I hope to see that same dramatic difference that I saw go into a commercial grove outside.
Yeah.
Unfortunately, I did the trial on Shiranui, which is a slow growing tree. So hopefully I'll have fruit next year.
I'll share this. I just finished up a trial in DeSoto County on the Valencia block, and we didn't use any algae, but we added biology, and we pulled Haney and BeCrop tests prior to applicating. And here's what I saw, and this is where I think an algae product probably has a fit, is that we went out with 16 ounces in the microjet irrigations, and we didn't see a whole lot after the 30 days post that first application. But after the second application, that's when we started cranking up the biology in that soil. And I think the aspect of, you know, the algae in there could probably help fuel and feed the biology a little bit, without a doubt. And so we saw those bacterial fungal ratios improve. And what was really exciting to me is we popped the flush on those trees. You know,
Yeah.
we kind of wake the hormonal response up on those trees, and they popped some flush out, and they really started blooming prior to our conventional time of, you know, for these blenches down here in South Florida to bloom. But just for the group, that the tool that I see in utilizing the BeCrop test is, you know, you're just not going to see data like this in a conventional soil test. But after that second application, we opened up those potassium pathways, and you and I both know we need cations to make bricks and sugar, you know, to try to get back to that 7-pound orange, you know. And we want to, I hope we're going to see the same thing on sugarcane, which we just started. So I don't know if you wanted to comment on that.
I think it's fantastic what you saw, that your trees flushed. That's exactly the same response I saw on one of my varieties. And I mean, we know there's a lot going on inside the tree to make it do that, and to be able to put it on the soil and bring that about is fantastic. So
last comment, and in summary, I'll close. But you know very well that large commercial citrus blocks in central South Florida, whether it's on the ridge or in the flatwoods, that we've glyphosated the heck out of underneath that canopy. So there's like no biological life there at all.
Yeah.
And so, but not only to point fingers at the citrus industry and the use of those herbicides, we see the same thing. My family, we grow sugarcane, and we're talking about black muck soils with 44% organic matter, high CECs, but there's still no biology in those black soils on the south end of the lake. So it's going to be some exciting work that we're going to probably look at here real quick.
You know, I think one of the things that could be done in both those situations is use some of these inoculants. I use some bacterial inoculants. I use a mycorrhizal inoculant. And then I think the EnSoil stimulates both of those. This year I'm going to a product that almost looks like a little honeycomb that does the same thing as biochar, that serves as a habitat for the microbes, and it's got nutrients in with it. So yeah, if after all that herbicide, and it's a more sterile soil environment, and so bringing it back, cover crops would help with that. But inoculants and then trying to feed the microbes, which I think is probably what EnSoil is hoping to do. You saw a difference, and I think that's really significant.
Herb, I would love to know what the product is, the honeycomb, inoculated honeycomb. Sounds
I'm gonna
really interesting.
just sort of discovered it today, and ordered some product.
Darcy said that they're trialing some wood vinegar this year, and they'll have to compare with you, Herb.
That's really interesting. I have some, and I'm not exactly sure how to use it yet, the wood vinegar, but that would be interesting. I'm looking for this product as we talk, but any other questions?
Herb, I can't help it. You sparked another comment when you talked about mycorrhizal fungi. It wasn't until after the second application, the biology that we applied, there was on the BeCrop, there was no mycorrhizae detected after the first application, but after the second application, it appeared on the BeCrop. So, and here's one thing that surprised me is that citrus green and probably knock 65 or 70% of the roots off those trees. So
Yeah.
you would think that we would try to be, growers would really be trying to increase that microbial fungi population to just add to root efficiency.
Absolutely. The interesting thing that you just described is it was there earlier, but kind of not detectable. And then once it woke up, which I agree with you. I think a lot of these microbes do, and then they get to detect, and then in the EnSoil helped it to do that.
Herb Doug is wondering, what did you use to feed the microbes early in the season?
Yeah, so I use several products from AEA, Advancing Eco Agriculture, and one of them is Rejuvenate, which it's a long chain carbons, so it's a mixture of probably malacid, humic acid, and fulvic acid, and maybe some other long chain carbons in there. And I use fish hydrolysate and kelp, and then another product that's a combination of humic and fulvic. So those are primarily, they're going out as fertility for the tree, but I actually put them out for the microbes also. And another product for microbes called M85 from Redox, and I've even used it during the wintertime. All these I inject. This product that's a honeycomb is called Humiflore, HUMIFLORE, and it's OMRI certified. It's a naturally mined calcareous. It was apparently kind of a diatom or a seashell. So it's blown up. It actually looks like a honeycomb, which is what people are trying to achieve with biochar, is all those little cavities for the microbes to live in.
Interesting. Thank you.
We have another question from Henry Austin. Was there a change in Brix levels, and can you speak about your monitoring of that? Also, did you see an increase in protists via microscopy, and how did you apply your ectomycorrhizal fungi?
Okay, Henry.
We can start with the first one, maybe.
Yeah, Henry and I have talked about, emailed about Brix, and I'm not happy with where my Brix levels are, and the difference in the conventional and the regenerative. I haven't seen the Brix level difference yet. And the University of Florida has a grad student actually working on that trial of mine, and they brought in a sophisticated chlorophyll meter. And actually, because apparently they're getting more nitrogen from the conventional fertilizer than they are from my fish hydrolysate and the organics, the trees are growing a lot faster. But as I'm watching that soil that's almost dead now, they're growing in kind of a hydroponic environment. They're, everything they're getting is what I give to them, as opposed to my regenerative that are getting the cover crops and the exudates and all the microbial things. Haven't seen
You're cutting out again, Herb.
With the honest, I'm going to open a door to my internet.
I see Gus in here. Gus, do you want to add anything to the discussion from our trials with biomakers?
Yeah, hey Meredith. I was
Hi.
just topped in a little while ago. Great discussion going on. And sorry I missed some of the data up front. I know a lot of this, I've gone over some of the BeCrop trial data with EnSoil, and one of the things I love what you mentioned, Herb, just now on different carbon sources, different food sources for the microbes, from the longer chain, more complex carbons to the simpler sugars, because that's kind of how you theoretically sort of hit both the bacteria, which like more of the simple sugars, and then the mycorrhizae and the other fungi that prefer more of the complex carbons, lignin, cellulose, and all sorts of other longer chain carbons as their food source. Well, one thing that you may have covered this already, Herb, but in the EnSoil trials, one thing that stood out to me was that there was a little bit of a response in the nitrogen, the pepper trial earlier in the season. And then I recall if it was either phosphorus or potassium that we saw some benefit later on at the second time point. Generally, as those peppers are going more into the reproductive, fruiting, and when they're really theoretically going to need more of that phosphorus or potassium. So that was just one thing that was kind of top of mind, if I recall those results correctly from the EnSoil trial.
Yeah, exactly. You're right. I do remember that. That was a neat response to the plant, and that the EnSoil helped it.
Mhm. Yeah, I think there was a 7% iron and more sulfur, and then also there was a 10% advantage to the inorganic end release at that time point. Is that what you're talking about, guys?
Yeah, I think that was the one, that inorganic nitrogen release. So that's the microbial function we look at biomakers that accounts for the nitrogen fixers and also nitrogen mineralized, the microbes that basically unlock non-available forms of nitrogen for the plant, convert either atmospheric nitrogen to ammonia nitrate through fixation, or convert organic nitrogen to inorganic forms through mineralization. So yeah, and then I think it was phosphorus or potassium that we saw some benefit later in the season.
To finish a little bit of Henry's question a minute ago, as far as microscopy, I have probably grown dependent on the biomaker's results to almost as if that's my microscope, because I see the species. They're all speciated for me. I've got a quantity, so it's incredible that you get the identity and the quantity, and so I've relied really heavily on that instead of trying to do the microscopy.
That's
and I think
incredible.
a lot of this technology that's new and dramatic is taking us to new levels.
Well, it's about 8 o'clock, everyone. We want to respect everyone's time. So tomorrow we will be sending out the recording of the webinar to everybody who registered. Stay tuned for that email. And if anyone has any last minute questions, feel free to stay on. I know Meredith and I can stay for a few minutes and chat with you all. We're also all happy to chat with you at a later date if you want to give us a call or send us an email. And we really appreciate you, Herb, for your time and sharing your research with us and answering everybody's questions.
I'd be glad to stay on too if anybody else has any.
Yeah, thank you so much, Herb and guys, for your work on this trial, the collaboration together. And I love that you mentioned the BeCrops, they're accessible for my crop. Oh, sorry, at the end of my day. But they make it accessible for folks who, wouldn't have those capabilities and those new features. They're just really, really wild to be able to go through.
I find it really
pieces like
addicting.
that. Yeah.
Once I do it, that's the nerd in me. I can look at them for hours.
And Darcy, just to your comment in the chat, we are super excited to work with you and are happy to support any help you need with collecting data, what to collect, how to collect it. That's what Meredith and I love doing. So we will be in touch with you for sure.
Absolutely.
Yes, Kevin, we do have people using EnSoil on tomatoes and in greenhouses.
Yeah, Kevin, we're happy to connect on tomatoes, helping you with some protocols or where to place it in your fertility program.
Yeah, actually, I just talked with my tomato grower yesterday, and he is also using some bacteria and some fungi. We're doing mycorrhizae, and we're doing a packaged bacteria from AEA as well. We're feeding that with a carbon source, a molasses, amino acid, and also what was interesting, he called me yesterday and he said, "What's wrong with my plants?" And I said, "What do you mean?" He said, "Well, I did 2 applications of EnSoil, and he said my bricks dropped down to 17." And I was like, 17? I said, "You didn't get over a 14 last year." So I thought that was very interesting.
What do you think?
So I'm
Herb?
still playing with the applications. So I'm not quite sure. Herb, you said how many applications did you do on those peppers?
Just 3.
Just 3 applications. So he probably should slow it down a little bit. He likes to use everything a lot. So I kind of have to wheel him back a little bit. And he's excited about a new product. So he's only had it for 2 weeks and he's already done 2 applications.
Oh, wow. Okay.
Yeah.
We did 2 initial.
Lancaster County, it's Lancaster County, more on. We got to put more on. If we see results, we got to go more on.
Lancaster County, great.
Well, definitely what we found with, using a micro amount of the algae is that it is very powerful and only needed that much. You can let them know we did do our dose rates, studies before starting the company, and, giving a double dose is not necessarily going to double
Increase.
the, yeah. Mhm.
Right. Yeah. I did mention that to him.
But I'm glad he's excited, and we'd
Yeah.
love to help him hone in on a successful plan.
Definitely.
Dropped all the way down to 17 his bricks. Oh my goodness, what a shame. Wow.
I know that's what I said.
I dream of 17 bricks. Gosh.
On tomatoes, I thought that was pretty good.
Yeah.
17 bricks and sugar cane on a 80 or 90 ton cane is going to make you a lot of money.
I bet.
I'm
Let's
sure
do
it
that
does.
next, Thor.
Thanks so much, everyone, for the great questions and conversation. This is always our favorite part of the webinar, is everyone getting to chat.
Yeah, and I want to mention, Camille and I have talked about this a lot to, include shop talk as, some of our webinars in the future. So if you have any ideas when we get off of things that we should be talking about, we get a lot of growers saying, "I'm doing this and I'm the only one in my area doing this, and I don't really have anybody to talk to about what I'm doing and how I'm doing it." So, we're trying to create a place for that here. One of the ideas is, how have you adapted your equipment to accommodate biological systems and things like that. So if you have any ideas, please share those with us. And yeah, thank you everyone for joining.
Thank you so much, Herb. Have a great night, everybody. Be in touch with questions and stay tuned for the recording tomorrow.
Thanks,
Thank you.
Herb.
Sure enjoyed it.
Great info, Herb. Thank you.
Thanks, Henry.
Thanks, Herb. Have a great night. Take care.
Appreciate it, everybody.
Bye.
Herb, that was so great. Thank you so much.
Yeah, thank you so much.
It's
This
so
was fun.
fun to listen
So
to.
fun. Thank you.
Yeah.
Yeah.
I
Okay.
understand more and more of how we can be helpful to others every time I hear you talking about what we've learned. So we all really appreciate you and look forward to more of this.
Thank you. It's been fun.
It's been fun. Let's have some
Yeah.
more fun.
Okay.